Okay, Trig, this is section 12.2, which is the first section about matrices. I wanted to kind of go through matrices and just touch on them a little bit before we end the year, because those of you who are juniors will see probably this again when you take the ACT and that type of thing. So um, yesterday we did, or I guess in the last two videos, we did solving systems of equations. So this is just two linear equations. You just have an x to the first power, y to the first power, and you're trying to solve and figure out what x, y is. So a lot of times what they'll do is they will write this system of equations as a matrix, and they call this an augmented matrix, okay? Because the augmented part has to do with the equal sign, okay? So they transfer that equal sign and they put a dotted line down the middle. Sometimes you will see matrices that only have like 1, 2, 2, 6. And this is a matrix that's not augmented because it doesn't have the equal sign. So these are just expressions. This would just be x plus 2y as an expression rather than an equation where you have an equal sign. And then this bottom one would be 2x plus 6y. So you always go in order x, y. If you have, like down here, we're going to have a z variable. You would go that route. Another thing about matrices is they have dimensions, so they will say a 2 by 2 matrix. That's what this is. So they always list the rows and the columns. Rows are first, columns are second. So this is a 2 by 2 matrix. This guy would be a 2 by 3 matrix because there's two rows, and 3 columns for that augmented matrix. Okay, so augmented versus ones that are not augmented have an equal sign versus not. Okay, so we're going to be dealing with some unaugmented matrices. I don't know if I'm saying that right even. In section 12.3 where we add and subtract and do that type of thing. Okay, so write an augmented matrix for the system of equations here. Here we have an x, y, and a z variable. So I'm going to start. Here's my matrix. I'm going to make him kind of big. You don't have to make him terribly large, but just so I have enough room to put things in. I'm going to have 3 rows and probably 1, 2, 3, 4 columns. So this is going to be a 3 by 4 matrix. Okay, I'm going to go ahead and put my augmented part in there. So that's kind of where my equal sign is. Okay, so and then I just put x, y, z's, making sure that they are in order. So I just put the coefficients out in front. Coefficient out in front of this first x is 1. Then I'll list 2 and 3. And he's equal to negative 2, okay? The second one, I don't have an x variable, or an x value, so I'm going to put a 0 in that spot. This guy's going to be a 2, and then I have negative 5, and that's equal to 6, okay? So you're going to kind of make your matrix large enough so that you kind of have space in between here so it doesn't look like 0, 2, minus 5, you know. You want to kind of put a little bit of space in between there. Last one is 3, 3, 10, and negative 2, okay? So there's a reason why we write these like this in matrix form, because we're going to do an example down below where we actually solve this when it's in a matrix form. And also in in the next video, we're going to, I'm going to show you how to plug this into your calculator and it will spit out the answer for you, okay? So even simple things like this, if you didn't want to do substitution or elimination, I will show you in your calculator how to do that or how to plug it in, and it will simply solve it for you really nice and easy. Okay, so we'll do that in the next video. So this is an augmented matrix for this system, and that was a 3 by 4 matrix or a 3 variable matrix. If we go down here and we talk about solving augmented matrices, okay. So this can get kind of hairy, but basically what you're doing is you're putting this into an augmented matrix and then you're kind of doing elimination to get this matrix into what's called reduced row echelon form. Okay, reduced row echelon form. Okay, so what reduced row echelon form is if you have a 2 by 3 matrix, which is what this one will be, like what we had at the very top example. Okay. What reduced row echelon form will be is you want your numbers to be 1, 0, 0, 1 on this side, and then you'll have whatever this number is over here, whatever this number is over here, okay? And what that will represent is this top row is saying 1x plus 0y is equal to whatever number this is, right? Or in other words, x is equal to this number. Okay, this bottom equation is saying 0x plus 1y is equal to this number, okay? Or really that 0x can go away, and then this bottom row will tell me y equals this guy, okay? So what I'm going to do, or what I want to try to do, is take this guy, put him into matrix form, and get him down to reduced row echelon form by doing some manipulation to get him to that point, and then I will have my solution. Now up here, if I want to get him into reduced row echelon form, which is going to be a lot more advanced than what the 2 by 3 matrix that we're going to do in example 2. If this one, I'm trying to get him to reduced row echelon form, what he would need to look like would be 1, 0, 0, 0, 1, 0, and 0, 0, 1. And then whatever number is over here off to the side. Okay? That's what he would look like in reduced row echelon form. And this would represent the x variable, the y variable, the z variable. And that would just tell me x is equal to this number, y is equal to this number, z is equal to that number. Okay? So I get him from here to this point. Okay? So let's go ahead and do one where we are putting him into reduced row echelon form, or we're trying to get him from this to this. Okay? And what we do to do that is we do elementary row operations, okay? And they say elementary, which makes it sound like it's easy, but it's kind of the same process of elimination, but just without the variables in there, okay? So there are legal things and there are illegal things. Legal things, you can interchange any two rows. So basically I can take these two and flip them around if I wanted to, right? I could put the 2, the 6, and the 2 on the top, and the 1, the 2, and the negative 2 on the bottom. So that's legal. I can totally do that, okay? I can replace any row with a non-zero constant multiple of itself. What that means is I can multiply any row by a number, okay? So that's kind of what we do for elimination, like here in this top equation. What I would want to do if I wanted to eliminate the x is I would multiply this top equation by a negative 2, and then that would get rid of my x. Okay, that's kind of the same thing as what the second bullet point is saying. All right, and then the third bullet point is saying replace any row by the sum of itself and a non-zero constant multiple of another row. Blah, blah, blah. That is just saying I can add any two rows together. Okay. I can add any two rows together, and I'm going to show you what that looks like. Okay, so those are legal things. Illegal things, I can't. Well, let's see. What would be some illegal things that I can't do? I don't know, anything that you wouldn't do normally when you're doing elimination. Like you can't do. Like I can't, mix my x's and my y's around. I wouldn't want to do that type of thing. So let me just kind of show you how to start out this process, okay? And it's, even though we're doing elimination, this is going to kind of look really funny, okay? So I'm starting off with my coefficients 1, 2, 2, 6, and then my augmented part, and then I have negative 2 and 2 off to the side, over there, okay? And so again, I'm wanting to get it to something that looks like this, all right? So what I'm going to do first is I want to, first of all, get this to be a 1. I work kind of backwards. I want that to be a 1, and it's already a 1, so I'm already at the first step. That's good. Okay. Then the next thing I want to do is I want to try to get this to be a 0. Okay. So I want to try to get rid of that 2 somehow. Okay. The third thing I want to do is I want to get this to be a 1, and then I want to get this finally to be a 0. So you kind of work backwards. You go from here to here, from here to here, from here to here. You kind of work in a circle trying to get those numbers to be that way, okay? So I already have this 1 in the right spots, and what I want to do is try to get that 2 to go away, okay? So here's what I'm going to do. I'm going to try to eliminate that 2, all right? And it's going to be exactly the same as what I mentioned up here. To eliminate that 2, or to get rid of the x, okay, I would multiply the top row by a negative 2, and add it to the second row, okay? So what I'm going to do is I'm going to write this as negative 2 R1 plus R2, okay? That's how we're going to write our row operations, all right? So I'll explain to you kind of how this works. I'm going to take that negative 2 times my first row, and I'm just going to add that to my second row, which is what I would do when I was doing elimination. elimination. Okay, negative 2r1 plus r2. So I'm going to go ahead and do that, and we'll see what we get. I'm going to write up here, I'm just going to write a little cheat sheet. If I take negative 2 times the top row, 1 times negative 2 will give me negative 2. 2 times negative 2 will give me negative 4. Negative 2 times negative 2 will give me positive 4. Okay? All right, now I want to add that to the second row. And here's where people get stuck. I want to add that to the second row, and I want to replace this second row with what I get new. So the 1, 2, and negative 2, that top row is not going to change at all. I'm going to change it, then add it to this, and that new stuff is going to go in the bottom row. Okay, so this guy, I can say equals my new row 2. Okay, so that stuff is going to now go into row 2. So after I add, or after I multiply by negative 2 and add it to positive 2, that's going to give me 0. Okay, multiply by negative 2, that's negative 4. Add that to 6, that will give me 2. Okay, then I'm going to multiply by negative 2, that gives me 4. Add it to the 2, and that gives me 6. Okay, so my new row 2 is negative 2r1 plus r2. Okay, so now I am at this point, I have that 0 there. That's what I want, and now I want to work on getting this 1 here. Okay, so I just, if we follow the 3 bullet points, I just actually did 3, like bullet point number 3. I added 2 rows together after I multiply one by the top one by negative 2. Okay, now the next one that I want to do, let me go. I'll put my new one up here. Okay, so what I want to do is I want to get this to be a 1. So how do I get that 2 to become a 1? Okay, now this is, I guess, where some legal things and illegal things come into play. What I can do to get that to be a 1 is I can subtract 1, right? But when you're doing substitution elimination, you would never subtract like 1y from this and subtract 1. We would never do that, okay? So what we would have to do is we would have to divide this guy by 2. So I'm going to take row 2, and I'm going to divide him by 2, and that's going to become my new row 2. Okay, that's totally legal since everything is divisible by 2. I can divide by 2. Okay, so the top row we're not going to change. 1, 2, negative 2. He's going to stay like that, but my bottom row will become 0. If I divide by 2 is 1, and if I divide by 2, that's 3. Okay, that's totally legal. Like this right here, if I would write it out, would say 0x plus 2y equals 6. Well, that's the same thing as saying 0x plus 1y equals 3. If I divide that by 2, right? That's the same thing. Okay, so my new row 2 is going to be divided by 2. Okay, and then I have that third one in place. And the last thing I'm going to do is I'm going to try to get rid of this 2, and I want to make that a 0. So I'm going to do a process that's kind of similar to what I did in the first step. Okay, I'm going to take this bottom row, which is row 2, and I'm going to multiply him by negative 2. Okay, because if I take this 1 times negative 2 and add it to this guy, it's going to make him be 0. Okay, so I'm going to take negative 2 times my bottom row, add that to row 1, except this time, that's going to give me my new row 1. Okay, all right, so if we take negative 2 times our bottom row, negative 2 times 0 will stay 0. Negative 2 times 1 will make this negative 2. Negative 2 times 3 will give me negative 6. Okay, and then if I add that to my top row, okay, this negative 2 and that 2 will end up canceling out, and that will give me 0 in this spot. Okay, so hopefully you can kind of see how this works. And I'm going to replace my row 1 with this new piece. Okay, so my second row is going to stay the same because he's all ready to go. 0, 1, 3, that's what he is. Okay, and then I'm going to replace my first row. So if I'm adding these together, 0 and 1 added together, that will stay 1. Okay, negative 2 and 2 added together, that will become a 0 now. And this is exactly what I want to have happen, those 4. Okay, and then the last thing, negative 2 and negative 6, if I add those 2 together, that will give me negative 8. Okay, so kind of just how we had before, this is in reduced row echelon form, so this is my final answer, but this is telling me that x, or 1x, is equal to 8, negative 8, and 1y is equal to 3. So x equals negative 8, y equals 3, or I can write it as negative 8, comma 3, as an ordered pair. Okay, so that's just kind of another way of solving it. This seemed like really kind of crazy weird, like why would you do that? Because that seems like a lot harder than elimination. But the more you do this, the easier it gets. And in fact, some people are able to do 2 steps at one shot. So really, I could limit this down to just 2 revisions of my row operations, and it actually ends up going faster than what elimination, like the longhand elimination, would be. Okay, especially if you get to ones that are like this. Okay, doing row operations like that would be actually a lot faster and easier than doing elimination with that whole thing. Okay. So just another way of kind of solving for that. If I wanted to check my answer, negative 8, 3, I can plug that back in. So negative 8 plus 2 times 3 equals negative 2. This is negative 8 plus 6 equals negative 2. Check, that works. Okay, if I check the bottom one, 2 times negative 8 plus 6 times 3, I want that to be equal to 2. So this is negative 16 plus 18 equals 2. Check, that works. Okay. All right. So, yeah, this seemed like a crazy process, but it goes fast once you do a whole bunch of it. Okay. All right. We're gonna do one more example, and then I'll stop this video, and we'll save the rest for the next one. Example 3: the matrices below are in reduced row echelon form. Okay. Now this one kind of looks funny, and I'll show you what this does here in just a second. Same thing with this one. Reduced row echelon form. Write the system represented by each matrix and find the solutions, if any. So some of these are not going to have solutions, and then classify each system as consistent with infinite many solutions, inconsistent, whatever. We're going to write out, because I don't really go with the consistent, independent, dependent, inconsistent, whatever. We're going to write out whether it has no solutions, one solution, or infinitely many solutions. Okay, so it has those as my options. Okay, all right, so looking at this guy, what this thing says, if I plug my x's and my y's back in there, if I put them back in, this says 1x minus 3y equals 4. Okay, 1x minus 3y equals 4. And then this bottom row says 0x plus 0y equals 0. Okay. So what's happening to this thing is that everything is canceling out in that bottom part, so that I only have one equation left over. And this was kind of like when you do straight elimination and you get like 0 is equal to 0, right? Like this bottom equation says 0 equals 0. Well, 0 is always equal to 0. So what's going to happen here is I'm going to have infinitely many solutions. And let me give you an example of that. Okay, so let's say x is 7. Okay, if x is 7, and I plug 7 in for x, y could be 1. 7 minus 3 times 1 is 4. That's right? Okay, now let's say that x is, I don't know, I can't think. Let's say y is 2, and that would make x have to be, what, 10? Okay, if I plug 10 in for x, minus 3 times 2 is minus 6, so 10 minus 6 is 4 also. That's another example. So I could have infinitely many solutions for this example because that bottom row canceled out to 0 equals 0. Okay, so that's just kind of what he looks like in reduced row echelon form. So yes, reduced row echelon form, we want it to come out as 0 or 1, 0, 1, 0, 0, 1, whatever, yeah, 1, 0, 1, 0, going around in that order. But when it is infinitely many solutions, you will actually have another number here as well. Okay. In part B, what this will look like, I have 1x, 1y, 1z. So this guy tells me that x equals 3, y equals negative 7, z equals 4. Okay, or I could write that as an ordered triple, which is 3, negative 7, 4. Okay, and even though that's 3 numbers, that's really only one solution. This is the only answer where x is 3, y is negative 7, z is 4. That will work for whatever the equation was to start with. Okay, so this one's going to give me one solution. Okay, now part C, if we write this out, this says x plus 2y equals negative 1. And this bottom one says 0x plus 0y equals 3. okay? Now this one's just a little bit different than what we had for part A, because that bottom one says 0 is equal to 3, which is not a true statement. There's 0 is not equal to 3. And this is one where we have no solutions. Okay, so that's what he will look like in reduced row echelon form when he has no solutions. Okay, so yes, the front part of this augmented matrix, so the front 2 by 2 and 2 by 2 look similar because they have two numbers in the top and zeros in the bottom. But if we look at the bottom parts, here it's 0 equals 0, here it's 0 equals 3, which is not true. Okay, so I know this is all foreign to you, this stuff, and I don't think they get quite as advanced as this on the ACT, but I really want to get to the next part where I show you how to do the calculator stuff, and then you can really use that, I mean, even as a self-check on the ACT to solve systems of equations. So like if they give you something like this on the ACT, you can just plug that in real quick and use that as a self-check to do that, and you won't have to do substitution or elimination. So we'll get to that in the next video. We should be able to do, I think, maybe all 4 of those examples. We'll see. We might have a part C video, but we'll see how far we get.